Great. Thank you for that introduction, Kathleen. Thank you for having me here today. It's certainly a pleasure to be here at this conference. Thank you to SIFPAC for putting on this multi-day event. And I just want to stress how appreciative I am and also the Loyola community to have a virtual event that our students can attend in between classes and at their own time. So thank you very much for putting on this great event. It's certainly a privilege to speak to you today and share the work that I've been doing over the past few years regarding soil lead and hemp. And I also just want to take this time to acknowledge the privilege that I bring to this space as a white male person working in urban agriculture. And thank you to all the others who are working in this space as well. And let's start with an introduction. Cool. So I am Kevin Erickson. I am the Senior Manager of Sustainable Agriculture at Loyola University. I will include my email also at the end of this presentation if you'd like to reach out with any additional questions or comments. I have a background of about 15 years of experience in food production. I've also been involved in teaching and training new food system leaders. Really proud of the students here at Loyola and the work that we do. I lead the urban agriculture program at Loyola University, which includes about 60 students per year. We do work in aquaponics, hydroponics, mushroom production, outdoor production. We also host a farmer's market. And the work that I'm going to be presenting today is my graduate-based research that I've been doing here at Loyola. And just wanted to give a quick shout out to the research team that I worked with, including Andrew Margenot of Universidad de Illinois, Ray Dybzinski, and Brian Osowski of Loyola University. One of my teaching mentors always told me to start with the takeaways or the highlights of the talk that you're going to give so that people sort of understand the sort of scope of what you're going to be including. So today we're going to really highlight how lead presents a significant risk in both soil and water. Mostly we're going to be talking about soil and crop risk. We're going to discuss methods to reduce lead exposure around crop production, for example, pH control, washing produce, or mulching. We are also going to talk about approaches for soil remediation, particularly immobilization of lead in soil. We're going to cover the cannabis plant. In my case, I was studying industrial hemp, which is a low or no psychoactive based version of cannabis sativa. It's essentially the same plant with two different expressions of cannabinoids. And among the findings, one interesting thing that we will also discover and talk about is the concentration of lead into the hemp plant is greatest in the root material, followed by herd or fiber material, and it's going to be lowest in the flower material, which is a really promising insight. Also, in the case of my research, I used phosphate or phosphorus to immobilize lead, and it led to more than a 200% decrease in uptake and movement of lead into the plant. So, in summary, the treatment that I'll be talking about was really effective in reducing lead uptake into the plant structure. And then also we looked at cannabinoids as a variable associated with lead or soil type, and one kind of interesting takeaway was that cannabinoid levels are generally increasing from the top flower position. They're generally decreasing from the top flower position to the low flower position. And we'll learn about how we separated different flower positions to measure lead and cannabinoids based on its position on the plant. Now, it's really important to mention lead and water. Because this is arguably a more pressing issue than soil lead. So very quickly, I just want to talk about some important aspects. Chicago is unique in the sense that we installed lead water lines through the 80s. And so currently we have a really big problem of estimated more than 400,000 lines that are laid in this city that need to be replaced. At the rate in which we are replacing them, it's not going to be done anytime soon. It's a significant cost both to the city and the residents. This is a really significant issue. The EPA says there's no safe lead levels in water. However, the guidelines that we have are based around a maximum consumption of concentration of 15 parts per billion. So you can actually get your water tested at home. I would recommend, if you haven't done this already, check out leadsafechicago.org. You can get water testing information, filters. You can submit an application to potentially get your water lines replaced. And moving it to soils, I wanted to just talk about some of the risks associated with soils. So we have both direct and indirect risks when dealing with soils. Inhalation and ingestion are the biggest direct risks. Most of the guidelines that we have around lead in soils are based on inhalation risks for children. We also present an indirect risk, which is the consumption of produce. Now, there's the uptake of lead into the actual crop product, but there's also soil that can stick to the side of the product, which is also part of contamination as well. Now, as far as guidelines for soil lead is concerned, the EPA lists 400 parts per million, which is associated with playground areas with bare soil that children would be exposed to. So it's not necessarily a garden application that creates this guideline, because currently there is no direct garden soil lead level guideline from the EPA. Now, other studies have suggested that a much lower guideline would be recommended when you are factoring in ingestion and inhalation risks. So the University of Minnesota recommends 100 ppm. The state of California is recommending 80 to 85 parts per million for lead in soils. And that's based on the maximum dosage rate allowed in children. So it would be my recommendation to stick to 80 parts per million if you're testing your soil, or have it be lower than that. You would want to take, I think this is just being conservative. And so I tend to sort of view the lower thresholds as probably better guidelines than higher thresholds. If you are getting your soil tested, heavy metals testing can be somewhat pricey. Tests usually start at about $50. There are lots of labs that do this work around the state, so I won't exactly mention one particular one. But you're basically going to get a composite sample of your garden area or an area that you intend to grow food. And that would be taking multiple samples over the area, mixing them together, and then sending that one sample into the lab. And that would give you sort of an overall look of lead levels in your space. Keeping in mind that lead can sort of pool in really high concentrations in certain areas. So it's not necessarily going to be mixed thoroughly throughout your soil. As far as testing goes, it's very expensive. The most affordable testing tool out there is called a PXRF, which is X-ray fluorescence spectroscopy. That's probably about a $50,000 unit. The most accurate way to test for lead is called ICP-MS, which is inductively coupled plasma mass spectrometry. And that's looking at a ratio of mass and charge to break down the specific ions in a material. So all that to be said, it's very expensive. Usually labs are doing lead testing work, but there are some XRF analyzers out there that are making the work a lot quicker and more efficient. Now, in terms of Chicago, we know that we have data specifically around lead in our soils. And this is going to be tied to a long history of materials that have been used in the city, whether it's leaded gasoline used through the 70s, whether it's paint, or whether it could also be water coming from our water pipes that have lead in them. We know that lead is in our soils and in our waters. A recent study, if you haven't had a chance to look at it, it's a really good study, came out recently last year by Margenot's group, or it was led by George Watson. It's called Soil Lead Distribution in Chicago. I highly recommend checking it out. Based on 156 samples of residential areas, they found that a median value of 146. But looking at parkways, which had a much bigger sample set, they found a median value of 220 parts per million. This is considered 10 times the concentration of rural soils of Illinois, or a comparison of what would naturally be found in soils. So keep in mind that lead is going to be occurring. It's a natural element that will be found in all soils to some degree. But when we look at urban areas, and specifically Chicago, it's very significant that we have 10 times the concentration in parkways. So we know that there's an issue with elevated lead levels. And if we're using the 80 parts per million threshold for safety, on average, there's definitely a significant concern when looking at Chicago soils. Also, this map came out as part of that study, which, it's the largest sample set that we have so far, and it's still somewhat of a limited sample set, but it does categorize geography and lead levels. And so looking at the legend in the map there, you can see anything that would be in the orange color or darker would be what the EPA considers unsafe for bare play areas or garden areas based on the risk of exposure. So that would account for, based on this map and this paper, quite a large geographic area of Chicago. And you can see the hot spots also on this map, which are generally going to be associated with industrial activity and historical activity in the city. It's also important to note here that urban farming, I'm sure a lot of us are aware of in this group, is a huge part of, or residential production is a huge part of urban farming. In fact, the bulk of food that's produced in the city and consumed is going to be from residential properties. So I think there's a need for a larger sample set, but also a need for residents to do their own soil testing and to calculate the risk of their own property. It's possible that folks are living on properties that are thousands ppm of lead, present an extreme risk for children and animals and people, and they're just not aware of it because they're not testing their soil. So really important reminder to test and be aware of these things. Now, some general safety tips in terms of lead and soils. If you're concerned about elevated levels and you're not, you're not sure how to go about mitigating the risk, I have some general thoughts. Number one would be sort of a common sense washing all produce prior to consumption. Previous studies have shown that approximately half of the estimated contamination associated with lead could come from surface dust on the outside of the plant, not just uptake into the plant. So cleaning your produce be very important. And as far as root crops go, they'll have the highest concentration of lead compared to other plant parts. So it would even be recommended for root crops to peel, scrub, and remove the outer layer of skin to reduce that exposure of any soil. So as far as plant part contamination goes, fruiting crops are going to be the safest bet. There was a study that was published recently by Margenot's group out of U of I that was actually using soils well above 1,000 ppm lead, which is considered very high. And they found 0 lead in the tomato itself, which is a really important finding as far as safety is considered. Compared to rooting crops and leafy crops, there will be a lot more concentration of lead. So fruiting crops are a safer bet. And like I said earlier about the surface dust, it'd be important to use a mulch to sort of limit that splashing activity or any soil from getting onto the outside of the plant. As far as leafy crops go, a good tip would be to remove the oldest outer leaves, which are also probably going to have soil on them. Older leaves are going to have more lead than newer leaves in leafy crops. And as I said earlier, covering soil with mulch to limit surface dust, keeping soil moist is also a way that you can limit dust as well. pH can play a part in the solubility of lead. So when we are in alkaline soils, meaning pH is above 7, lead is less soluble, meaning it's less bioavailable to the plant. So noting that most recommendations around pH for vegetables will be, slightly on the acidic side, maybe 6.2 to 6.8. Keeping your soil closer to 7 or closer to an alkaline pH value would actually increase or help creating solid compounds that would not be bioavailable. Also, adding organic matter compost is a great tip. Organic matter will bind to lead and form organocomplexes, and these can be non-bioavailable to the plant. And it's also important to note that lead is not going to be at high quantities in deep layers in your soil. It's largely going to be concentrated in the top 6 inches of your soil. For the purposes of my study, I measured the top 15 centimeters of the soil, which is close to about 6 inches. I was also part of another study that looked at the soil lead concentration below at different depths, and there's a huge drop off that occurs after 10 to 15 centimeters. So that's a really important piece to this. You don't have to dig out all of your soil if you are planning to remove it. It would just be the upper 10 to 15 centimeters. Okay, now in terms of if we're dealing with lead-enriched soils and you want to do something about it, okay, so maybe you're taking precautions as far as harvest and preparing produce. There are some strategies that are out there that can help remediate or possibly reduce exposure to lead. So a project that I was involved with called the Rodeo Farm many years ago is an example of a cap and fill, where we took an existing parking lot, gravel lot, capped it with a permeable barrier, and then filled soil on top of that. So that's a really common method. Some people may find that the lead levels are so high in their soil that they just want to remove the soil altogether and maybe that top layer. So that's a really common method. There are studies out there now that are focusing on phytoextraction or phytoremediation. And when we say phyto, we're meaning plant or light. So it's the ability for a plant to basically grow and uptake metals, in this case, lead. And so there are some plants that have been identified as these lead accumulator plants, some more than others. And I have previously done work with Indian mustard or Brassica juncea, which is a really high accumulator of lead. So it's just some other examples, sunflower or even basil as a possibility. Now, when you talk about phytoextraction, I should mention real quickly, there's concern that the product that you're growing may be contaminated too far beyond the point to actually sell it or actually, feed people with it. So we also have to be aware of the risk that's involved in phytoremediation. In many cases, you may not want to be consuming the product itself if it has a high degree of lead or other heavy metals in it, and it may be illegal to do so. Getting into another idea of immobilization, this is a soil treatment. So as I mentioned earlier, we can think about creating alkaline soils. In general, urban soils tend to be more alkaline, so this is probably a bonus towards immobilization. But alkaline soils will reduce solubility of lead. Adding compost, adding other substances like bone meal, which the main component is hydroxyapatite. These are things that can bind to metals and make them less bioavailable to the plant. And one one particular strategy that's been pretty well studied, and one that I used for my research, was creating or using phosphate to bind to lead to create lead chlorophospate. And another term for that is called pyromorphite. And this is a thermodynamically stable compound. So basically, it can, if it's heated up or cooled, it will remain stable, and it's very pH stable. So it's basically a way that you can tie up your lead in your soil without making it bioavailable to the plant or human if they were to ingest it. And so this is an example of pyromorphite, if you were to find it sort of naturally occurring. But there has been a study out there that I reference for my work as far as a rate of adding phosphorus or orthophosphate in order to achieve immobilization. And that's based on other positively charged metals that can exist, or heavy metals that can exist, such as cadmium and zinc. And so when we create our treatment, it would be based on a 4-to-1 ratio of molar mass, phosphorus to these 3 metals that are listed. So it ended up being, I ended up using a lot of phosphorus in my project. There are some disadvantages of using a lot of phosphorus too, and environmental risk, but this was sort of the basis behind my project, was thinking about soil lead immobilization to reduce uptake into the plant. Now, industrial hemp is a really interesting and sort of novel plant in the sense that it hasn't been well researched, partly due to the fact that it was illegal to grow and had very limited research accessibility up until the 2018 Farm Bill, which sort of legally separated cannabis, psychoactive cannabis, with non-psychoactive cannabis, or what we call industrial hemp flower. So legally speaking, we would define industrial hemp as containing less than 0.3% THC delta 9, and that is the primary psychoactive ingredient. So to be very brief, industrial hemp will not get you high, or you will not have a psychoactive experience based on using industrial hemp. And there's quite a bit of uses for this plant. Most of the psychoactive based hemp, or excuse me, psychoactive based cannabis is produced for the flower, whereas when we're growing industrial hemp, there is an application of using lots of different plant parts for different things, whether that be fiber for clothing or building materials. Leaves are now being used for livestock feed. And of course, the inflorescence, which would sort of be the scientific term for the flower material, which now has quite a strong CBD based flower market behind it. Now, there have also been studies looking at hemp as a phytoremediation candidate, and that's where I started this sort of research concept or idea, was thinking about the risks and the sort of variables involved with phytoextraction. Now, typically this is going to be done in by using industrial hemp for fiber. So it's a little bit different than growing hemp for flower production, because you have a really dense planting that's going to have a lot more ability to uptake lead in a smaller area. So you're able to grow more biomass and hence be able to take more lead out of the soil. Previous studies have shown that flower may actually have more lead concentration than other parts of the plant, which was also very surprising and sort of led me down the path to want to investigate that as well. And most of the studies that are out there have not been able to differentiate between crop uptake and surface dust adhering to the outside of the plant. Imagine if we're in a large field that has contaminated soil and we're not accounting for surface dust. A lot of that we're measuring and analyzing in the plant material will contain that surface dust, and it will be a problem when we're trying to sort of suss out, well, what was surface dust and what was uptake. And so this was a really important part of my work as well, to really look at what is the uptake and what we call translocation or movement of lead into the aerial parts of the plant, separate from the surface dust issue. So there have been studies out there showing that hemp may be a good phytoremediation candidate. Some studies are also saying it may not be, based on its accumulation of lead, and maybe it's not taking out enough. Of course, anytime you are doing phytoremediation, you may be left with a high lead concentration in your product, which may actually render it unsafe to use. There may be applications like building materials, which could use highly concentrated lead, you know, in the biomass, which may not have a significant effect on humans. But it is a concern if we're talking about using a plant to uptake a heavy metal and then potentially selling that plant on the open market. It's also been noted that cadmium is another metal that hemp may be a strong candidate for remediating or removing in a fiber-based production scheme. It's also important to note here that there are, as I just mentioned, legal considerations around the materials that we use and the amount of lead in them. If we're talking about hemp flower specifically, the state of Illinois guidelines are that hemp flower material, whether it's inhalable or not inhalable, it includes all hemp flower products, they have to have less than 1 ppm or milligram per kilogram of lead in them. So if we're planning on potentially selling these products in the scope of flower, it would need to have less than 1 ppm. Now, here's a picture of what a fiber-based plot would look like. Okay, so these actually are producing flower, or they may be producing seed, but you have a density of potentially up to 100 plants or more per square meter, which is very tightly spaced. This is, you know, not what most people think of when they're growing cannabis. And so this is sort of the way that we're going to grow these really tall plants that have a lot of biomass and are going to be able to uptake metals such as lead. And when we remove that biomass, we're able to lower the lead levels in the surrounding soil. Now, in terms of hemp flower is concerned, this is what hemp flower production would look like. It's a lot more spaced out. So hemp flower as a phytoremediation candidate may not offer the sort of same extraction levels because it's much less dense. But this hasn't been very well studied, and there needs to be more information about the risks associated with hemp flower grown in contaminated soils. So along those lines, an important aspect of the value of hemp, or even really all cannabis flowers, associated with cannabinoids. There's also value associated with terpenes, or what are called terpenoids. Specifically, there's required testing for cannabinoids. And as I mentioned, CBD flower must contain less than 0.3% THC. So there have actually been previous studies that have looked at growing cannabis plants or hemp plants in lead, in these highly enriched lead soils, to see if that is changing the expression of cannabinoids. And that was an initial question that I wanted to ask in my work. And so that is something we're going to learn about today as well. The highest concentration of cannabinoids, which there are over 100 that are measured in the cannabis plant, there are only maybe 10 or 12 that are usually tested. So there are a lot of cannabinoids that exist that we don't currently have testing routes for. But most of the concentration of cannabinoids will be in the glandular trichomes of the flower material. There are trichomes located on other parts of the plant, including leafy material. So there are cannabinoids present in leaf material as well, but the highest concentration is usually associated with flower material. The hemp CBD flower market is very interesting. It's actually had somewhat of a decline over recent years due to a lack of full market development and processors. It's also CBD and hemp flower has not been identified by the FDA as a official drug or treatment. I think that would also help drive its popularity. But currently there's, at least in 2021, there's a $620 million market for CBD flower. So it's still a pretty significant market. And some really important questions driving behind this would be, can we grow hemp flower or cannabis flower safely in highly enriched lead soils? How much lead would be going into the flower or other parts? Does this present any risk in terms of selling it? And then secondly, is the expression of cannabinoids potentially altered by lead? The treatments that we use in the soil, in our case, phosphorus, or can we even find any differences in cannabinoids as a variable of plant flower height? So I looked at, I'll explain it in a minute, but I looked at 3 different positions of the flower where they're occurring on the plant. So for my, why don't I, before I keep going, I will pause for a second and see if there are any questions that I could answer quickly about lead or lead in soils before I move more into my research.
Thank you, Kevin. We actually had a question a few minutes ago, not minutes, just a few slides ago. Veronica Medina, feel free to hop in if you wanna add to your question, but she asked, should we avoid composting plants grown in lead contaminated soils?
Yeah, it's a great question. I would say yes, if you are concerned that there could be elevated lead or you have been growing those crops in known elevated soils. Of course, there's going to be a higher risk with root and leafy material than there would be with fruiting or flowering material. But if you are planning on trying phytoremediation, you would not want to break down your biomass in your normal compost, because that would just be concentrating the lead and putting it back into your beds. There's no gaseous phase of lead. Okay, so when you have lead in the biomass, it can be disposed of by making it into building materials and using it in a way that's not exposed to people. Yeah, maybe I'll just stop there with that point. But yes, you'd want to be very careful about composting high lead concentrations in biomass.
So going off of that question, should you be soil testing your compost if you are composting at home or in your backyard or community garden?
Yeah, sure. I think testing your compost could always be a good idea. It may be cost prohibitive, but if you are testing your soil initially and you know that lead levels are in a safe range, there's no reason to believe that you would have super high accumulations in plants. There are some plants that will uptake more lead than others, but from the work that I've seen, levels at 100 or less, or 80 or less parts per million are not going to be super significant.
Okay, thank you.
Okay, should I keep going?
Yes, if anybody has any questions, feel free to drop them in the chat, and I'll make sure that I voice them. Thank you. Cool.
So to sort of switch gears and talk a little bit more about my research and the summarizing it. I wish I had about 2 hours or more to probably go through every single thing that I did. So I'm gonna really kind of highlight the major points here. But basically what I did was I found a location in Chicago, in Pilsen, that's a residential soil. And the soil had been tested to have elevated levels of lead. And so I found soil from 2 different parts of the yard, and I removed the soil in plots, and then I mixed it together and I grew hemp plants in them. And so here's the data for the 2 soils. And as you can see, somewhat similar characteristics in terms of quantities, both alkaline soils. There's a little bit difference of a pH that makes it difficult to sort of compare these 2 soils. But when you look at lead levels, what was interesting there is you have around 1,000 ppm and 2,000 ppm, and those would be representative of extremely high lead levels that hopefully people would not be growing produce in. But we really wanted sort of see the performance of these soils and how much lead was getting into the plant. We also measured things like phosphorus and exchangeable phosphorus because that is a significant aspect of the immobilization component as far as binding to lead. And as you can see, there are also other metals that were measured here, including cadmium, which would be considered a somewhat elevated rate. But pretty standard soils for what you might find in terms of organic matter in a residential area. pH is similar to what we would find in Chicago urban soils, which previous studies have shown that urban soils tend to be slightly more alkaline. Now, here's just a wall of text. It's basically a bunch of information about the methods. I've sort of covered them a little bit already, but I'll just kind of go through the highlights of sort of the experimental design. Each plant was grown in a 20-liter pot consisting of 25 kilograms of soil. So this is a pretty large pot per plant. And then I used 4 different treatment groups. So there would be 2 different soils, call them soil A, soil B. And then I also had an added rate of phosphorus, which was based on that equation that I gave earlier, a 4-to-1 ratio of phosphorus based on lead, zinc, and cadmium levels, based on the molar mass of those elements. We had 32 total plants. And first of all, I must say that growing 32 hemp plants in a university greenhouse took me a lot of time to get permission, and I have a lot of respect for administrators at Loyola who let me do this. It was a highly visible project, and it smelled. It was very funky. I thought I was, that would have been a concern, but honestly, people were really open to it, and so it was the first cannabis-based production project on our campus, and I'm really thankful for just being able to do it, having permission to do it. So moving on, we, accounting for soil covering, we use perlite to cover the soil to make sure there wasn't any dust kicking onto the plant, as I mentioned earlier. The variety that we use is called CBF1. It's based on a cherry blossom, which is a really common hemp variety. And we produce the plants over 118 days, consisting of about 2 months in the vegetation stage and 2 months in a flowering stage. That's pretty common if you are growing cannabis flower. The project took place in our greenhouse lab, which we provided supplemental lighting, temperature adjustments, measured moisture on a daily basis, and then we added some fertility to start the project based on guidelines for hemp production. And then following the harvest of all the material, we analyzed the flower material and all plant parts for lead, mostly focusing on flower material. We also measured cannabinoids as a variable of flower height position, which I'll talk about. And that flower height position was based on the top or the peak of the plant. And if you're going down the main stem, it was taken at 10 centimeter increments. So at 0 to 10 centimeters, flower material that was growing from 0 to 10 centimeters from the top versus 10 to 20, which we called that the mid position, and 20 to 30 centimeters from the top, we called the low position. And so this was the first study that had actually quantified flower position based on cannabinoids and lead, which was sort of novel in that aspect. Now, here's taking safety precautions here. Here's a picture of me with the homeowner at the actual residential site where we pulled the soils from. It's important to note here that the homeowner knew the soils were elevated in lead and was not allowing his kids or dog to go in the backyard. It was totally cut off from use. And so part of this project was just helping this homeowner revitalize their space so it could be useful to grow plants and have a fun space to play with their kids. So this was removing the soil in those different areas of the property. We think that this garage located on the rear of the property was a source of lead paint. that was disposed, or that was flaked off the garage and was in the surrounding soil. But there could have been also other forms of lead existing in that space. Just to show a picture of the project space here at Loyola University, this is right before harvest of the hemp flower plants. You can see supplemental lighting and heating mats and some sticky traps. And then a picture of the flower material sort of in its last stages prior to harvest. You can see these adjacent leaves on the flower material. Those were removed during the harvest, so we really wanted to just isolate what would be considered usable flower material. But it's interesting to note these leaves in the bud material, they're also known as sugar leaves, and they can contain high levels of cannabinoids, which would be greater than the level of cannabinoids in other leaves of the plant. So just a summary of the results of this project, and then I'll get into some specific data points here. So overall, industrial hemp plants showed no major signs of stress and were really productive in highly enriched lead soils. I think that was a really good outcome, is you can successfully grow hemp flower in these soils. You know, other studies have shown germination decreasing, plants not as large, not as high yielding. We saw significant yields, significant height of the plants. They looked very healthy grown in these high lead soils. The added phosphorus treatment significantly reduced lead uptake and translocation into the flower and plant parts by as much as a 200% reduction. That was a really important finding in the study. We'll cover the data in that shortly. Also, the added phosphorus significantly decreased the pH of the soil, which changed some of the lead solubility, but also it made it difficult to sort of compare the two soils side by side. When you have slightly different characteristics, including pH, it's very difficult to make a conclusion that soil A, behaved this way in relation to soil B. Compounding that factor is the idea that we can't spike the lead into the soil. We can't just add lead in the form of lead nitrate at two different dosage rates and compare the two different soils. That has been proven to not give you a realistic picture of what is happening in the soils, because that lead would be a lot more soluble in that lead nitrate phase. So we kind of need to study real soils, not just treated soils in a lab, but to get real soils and grow plants in them and see how they're behaving. Now, in terms of lead in the biomass, or as far as the flower biomass, we generally saw an increase of lead from the top position to the low position. So as you're moving from the top flower pieces to the lowest, there was generally more lead. So lead was basically increasing as it went up the plant or decreasing down the plant. And cannabinoids were not significantly influenced by lead level, and that was just based on the pH issue, that we couldn't compare the two soils and say, oh, soil one with less lead influenced cannabinoids differently than soil two. So unfortunately, we can't draw that conclusion based on this research. Interestingly, though, if you're growing any cannabis, I think the measurement of cannabinoids is very relevant. The trend that we found in general was that cannabinoids were decreasing from top to low flower position height. There were some exceptions, and I will talk about that specifically here shortly. And contrary to previous work as far as the plant part concentrations of lead, what we found in our study was that root biomass had more concentration of lead than fiber or herd material, which would be located in the central stem material, followed by leaf material, followed by flower. And so this is a really interesting finding, because we were able to isolate the uptake factor and translocation factor from the issue of surface dust. And I think that previous studies were not doing that, and therefore the data on the plant part concentrations was not as exactly accurate in pertaining to the uptake factor. And so this feels very novel and interesting in terms of measuring different plant parts and expecting, concentrations relative to each. Okay, so getting into the data, we have a couple of graphs here. So the two boxes that you see here are representative of the two different soils that I use. So soil A at about 1,000 ppm lead, soil B at roughly 2,000 ppm lead. Now this first graph is looking at the total flower biomass. So on these lines are connecting the mean values between each of the treatment groups. So you can see in soil A, without the added phosphorus, there was about 57 grams on average, and increased to having more flower yield in both cases, in both soils, when added phosphorus was added. So these yields for the hemp flower are fairly consistent with data that we have for other hemp varieties. There's not a lot of information out there about this particular variety, but we can conclude that the yield of flower was significant, was good, was not something that is going to give us an extremely low flower yield because we're growing in these enriched lead soils. Similarly with plant height, we had large plants similar to what we would find in a field setting without lead enriched soils. And in both cases where the added phosphorus was used, it increased the height of the plant and both the biomass as well. So just summarizing that information, really healthy, productive plants grown in these soils, no major signs of plant stress, and the added phosphorus increased both flower biomass and plant height. Now, moving into the lead measured in the flower biomass, you can see here that there was a significant trend of lead slightly increasing from top to bottom position. So you can see I have on my graph here top, mid, and low position, and this would be representative of soil A and its added P treatment. And then I have the other soil with the control and the added P treatment. So all of this is just saying that the lead increased slightly from top to low position. So there's essentially going to be a little bit less lead in the top flower material. And it's important to note here that the 1 ppm mark here is where the legal threshold for lead in cannabis products is. And so if we're looking at soil B at roughly 2,000 ppm lead, none of our flower products would have been legal as far as lead contamination because they're all above this 1 ppm threshold. Whereas when we added the phosphorus and that really high soil B, some of the flower material was actually legal in terms of lead concentration. It's much more significant in terms of soil A because you go from mostly illegal concentrations of lead in flower material moving to all legal concentrations when we added phosphorus. So this is really cool because our phosphorus treatment actually made our hemp flower go from illegal to legal in terms of being able to sell it. And so surely there are other treatments that could be effective in doing this, but this is a really significant finding here that we're really excited about. Now, when we just go outside of flower and we think of the entire plant, I wanted to look at different plant parts, but I also wanted to get a sense of, okay, well, if I was to remove each of these plants from the site area, how much lead would we be actually accumulating in that entire mass? And would there be a change in our sort of soil levels of lead? Now, so in terms of looking at above ground biomass compared to root biomass, there's a root biomass at the highest concentration compared to other parts. And you can see the total, this is the total amount of lead removed in each of our treatments. So in soil A, the most lead we could remove in the total biomass was 1.23 milligrams. And if we equate that to a parts per million basis, we're really not lowering the lead parts per million much. So conclusively, this would not be a really good phytoremediation candidate because it's not accumulating enough lead to reduce the lead soil levels. Now, what is interesting here is the fact that we have also shown that we could be growing hemp flower in highly contaminated soils, but also potentially produce a legally safe product. And so I think that is probably the more appropriate angle to think of hemp flowers. It can be grown in highly enriched soils. It will produce a really good yield for you. It can be grown in highly enriched lead soils and produce a safe flower product, but it's maybe not going to be the phytoremediation candidate that's going to lower your soil levels over time. Now, this was also interesting because, and this is a chart looking at each part of the plant, and we noticed a trend of roots having more concentration of lead than fiber, which would be the hurd or fiber. In our case, we did not separate the hurd and fiber, which can be commonly done in this work. And leaves had more concentration. Leaves had less concentration than fiber material, and flower had even less than that. And then in the flower material itself, as I mentioned before, there's going to be a slightly higher concentration of lead in the lowest position compared to the top position. Now, switching gears away from lead concentration or lead uptake in the biomass, we also wanted to look at the cannabinoid expression associated with these plants. And so in summary, we found that most of the cannabinoids are decreasing from top to low flower position. And that would include CBD, CBDA, CBN, CBGA, and THC delta 9. I'll show you a graph here in a second. Now, this was also really interesting. There was one cannabinoid that was actually increasing from the top to the low flower position, and that was THCV. If you look at this graph, THCV was not present in any of the top or mid flower height positions, but it was present in the low position. This is really interesting, has never been found or discovered in the research previously. And I would be very interested to learn more about the precursors and development of cannabinoids to understand how they could be differentiating in quantity at different levels. Furthermore, there were some cannabinoids that didn't show significant trends in increasing or decreasing. That would be THCA, or the acid form of tetrahydrocannabinol. And there were some cannabinoids that were not detected in all of our samples, namely THC delta 8 and CBL. And of course, as I noted with pH, there was not a significant, we couldn't conclude that soil lead level was a significant variable in terms of changing cannabinoids. Now, this is really cool because it's showing the general decrease from top to low position of cannabinoids. So if you look at CBD or CBDA, you can see from the top to the mid to the low position, this general trend across all treatments of it decreasing. Similarly with THC delta 9, which is that main psychoactive component, you can see that it's also decreasing. And this is really interesting because if you look at the legality of THC delta 9, which is at 0.3%, a lot of these samples in the top position would be considered illegal. So having consistent sampling throughout the entire plant is really important here, because you can see that these really high levels above 0.3% would actually render that material illegal to sell. And so in all cases, we did not have any THC delta 9 levels that were considered above the 0.30 threshold. Now, another potential problem that I wanted to share with using TSP or triple superphosphate, which is what I use for my treatments, is that it can potentially have cadmium loading, which is basically cadmium in the material. And this was a significant problem with my research that I wanted to just be transparent about. You would want to use a phosphate source that doesn't have other heavy metals in it. Because I found cadmium was at levels that were considered unsafe in the flower material. And that is a really significant finding that I didn't want to not include But had I used a phosphate material that didn't have cadmium or as much cadmium, that would have not have been the case. So really important to note there. Moving on, I know I'm running out of time here and I want to have time for some questions. So some further research could be reducing the solubility of the phosphorus so that it's not an environmental risk and leaching out into waterways, because that can be a problem for phosphate. I talked about cadmium loading, which can be a concern for using phosphate rock. I think we also need to do more field studies to understand the difference between uptake and surface dust, confounding the issue of concentration of lead into this hemp material. I think multiple varieties would also be important to study to know the differentiation or comparison of lead into different varieties. There's going to be some variation happening across multiple types. And another important part would be identifying speciation of lead. Lead is going to exist in different forms. It's not really found in its elemental pure form. And so there are some species, if you will, or types of compounds of lead that are more bioavailable than others. And understanding the speciation in relation to the source of lead and where it's coming from would help us understand and mitigate risks. And there is a test out there that is available that actually will mimic human digestion of lead. It's called a PBET test. It's very expensive and only a few labs are doing it at this point. But it sort of represents the next level of looking at food products and actually simulating how much would be digested and remain within humans if they're consuming these products. So that's a really interesting development that we would want to pay attention to. And then I think having a better matrix or assessment of soil lead on our site, not just taking one sample, but maybe multiple samples to create a matrix of where lead is existing in higher or smaller quantities would help us be able to prepare and maybe save some money in how we develop land. I'll include my resources on here if anyone wants to check them out. And I'm including my email address. I'm also including one of my advisors on this project, who is an expert in soil lead specifically. I would consider him, and there are others doing work in the space, to be more of an expert even than me on soil lead and soil lead mitigation. He has a lot of published papers out there, so I would highly recommend reaching out to Andrew if you're interested in taking on a big project as well. And with that, I will hold for questions, and just want to thank everyone who helped me with this research project, and some of them are even on this Zoom meeting today. But thank you to Loyola. Thank you also to SIPPAC for providing the space for me to share my work. So with that, I'll open it up for any questions.
Feel free to drop in your questions in the chat. I'll raise them to Kevin. I did have two questions raised in the chat. One of them was by Veronica. She asked, so what should we do with the plant materials? Feel free to add a little context to that, but I believe that what she meant is, if your soil in your garden, it has elements that need to be remediated, and they're composting with this, what should you do with this organic matter after it becomes organic compost? Yeah,
so you could use the organic matter compost in an area that doesn't have edibles. You could potentially burn the biomass and have a concentrated form of ash that could be disposed of. Or you could potentially landfill the material and have it avoid the compost waste stream.
Before we hop into this next question, we had another one. Did air quality increase or decrease in the grow medium?
Air quality. Oh, interesting. I'm not sure. I didn't test air quality. That would have been that was an element that we looked at, but it was not part of this analysis, if I'm understanding the question correctly.
Okay, thank you. Wendy Hernandez asked, do you know of any programs that offer free soil testing?
Good question. There was a Safe Soils initiative that was doing soil testing. I don't currently believe they're doing it now. If anyone knows if that is the case, maybe enter in the chat, but I'm not aware of any free soil testing at this point, but there was a free soil testing service out for several years. I think that has ended, so I'm no longer aware of that. I know AUA has a soil testing program that is designed for like businesses or programs that are starting a new site, but it's not really aimed at residents or individuals.
I would also like to shout out Food Navigators. The app is officially open to the public. They may have, it's basically a network of growers and farmers throughout the Illinois area, concentrating in Chicago. They might, if you throw in the question, somebody might have some feedback or resources to share. Oop, there was a couple questions. Alicia asked, would rinsing the flower material be sufficient to isolate the uptake and surface area of PB testing?
Good. Yeah, that's a good question. Washing of the flower material could be problematic for quality. You're harvesting them and drying them. I haven't seen any particular studies that have worked with cannabis in this way, but there are some studies out there using what's called an EDTA wash, which is a binding agent that can stick to lead really well and chelate lead, and so there's potentially a process that would include an EDTA wash that would grab the surface bound lead particles, but it will not reduce lead particles that are in the structure of the plant through uptake. But great question, thought there. Yeah.
Thank you. Unfortunately, I'm going to